I've lived through a long period of time when I've seen people say neural nets will never be able to do X. The collected works of Gary Marcus is a nice history of that. So I don't believe those statements anymore because for almost all the things people have said, they can now do them. You know, proving a mathematical theorem used to be something, well, neural networks will never do that. And people just keep moving the task, making it harder and harder. And I completely agree with Demis. There's no reason to believe there's anything that people can do that they can't do. They may not be able to come up with profound new mathematical conjectures yet, but that doesn't mean they won't be able to in 20 years' time.
So everyone's talking about Q star, the rumored advanced model from OpenAI, the one so powerful that everyone got scared and tried to delete OpenAI off the face of the earth. Everyone wants to know what it is, except Gary Marcus. He says, I got 99 problems and Q star ain't one. I got to give him style points for bringing Jay-Z lyrics into this, but still Marcus. One absolutely incredible thing that we witnessed over the last 48 hours since this whole rumor of the Q star came out is people from all over the world, ranging from top AI researchers to random people on Twitter, have been looking into trying to figure out what this Q star thing is. And everyone's gathering information and presenting the information to the world. And I got to say, it's kind of mind-blowing to see. It's like this crowdsourced search for the answer. And what's really interesting is that the ideas, the theories, the hypotheses we're coming up with, I don't think they're that bad. And in fact, I'll show you why some of them are probably what's coming next, the next big breakthrough. Whether we'll find out later that this is, in fact, Q star or Q star never existed. The interesting thing about this is I think we're getting a glimpse into the future of AI, and it's unfolding based on these sort of crowdsourced efforts from, well, us, you, me, the rest of the people talking about this. It's kind of exciting, I gotta say. So first and foremost, yesterday we went over sort of breakdowns of what Q star could be. One was by Dr. Jim Fan and the other by Nathan Lambert, the Q hypothesis. So these are AI researchers, very smart. They know their stuff. They cite a lot of sources. My sort of takeaway from this thing is this. Since we have GPT-4, since the release of GPT-4, a lot of different advancements have been made in how we utilize GPT-4. We have tree of thoughts, how to approach searching for solutions to certain problems in this sort of branching way, similar to how humans think through problems. We're teaching this AI, GPT-4, or some other neural net, some other large language model, to think through certain problems, similar to how you or I would do it. Another idea that seems to be working very well is having the AI kind of grade itself. Or maybe you can think of it as two separate instances, two different AIs, one grading the other. So as one produces outputs, the other one goes, good job, bad job. So that's referred to as RLAIF. So normally we have reinforcement learning with human feedback, where human grades the AI's outputs going, good job, or that's not good. Thumbs up, thumbs down. This is RLAIF, meaning the AI is the one grading the other AI. The other big thing that popped up just recently is Orca 2, which is a Microsoft open source model. What that seems to be showing is that larger, smarter AI models can teach other models. So they can produce data, what we call synthetic data, to teach the next generation of AI models. And the next really big thing, kind of adding on top of this whole thing, is adding the ideas created with AlphaGo, Google DeepMind's star pupil, and using GPT-4 and everything that we found out about LLMs, and combining that with everything we know about AlphaGo. Now, when I say AlphaGo, obviously that's a proprietary Google DeepMind technology, so it's not AlphaGo, but some of the ideas that we've learned about it, some of the approaches that they have, because LLMs and kind of what's happening behind AlphaGo are two very different kind of forms of AI. And they're excellent at very different things, and they both kind of have these weaknesses, and combining kind of the findings from each, combining the powers of both, could be the next big leap forward. And that, I don't think that's just a speculation. It's not just a theory, because as I was recording the video going over this theory, what I was not aware of is that in Andrej Karpathy's new video, Intro to Large Language Models, and again, this just came out 3 days ago, I believe. What I did not know is that kind of buried deep towards the end here is there's this little chapter in the video called Self-Improvement, LLM AlphaGo. He's basically saying the same thing that we covered in the video from 2-3 days ago. And he is one of the top guys at OpenAI. He probably knows everything or most of the things that's going on there. And this is his kind of where he sees things going.
And the second example I wanted to give is this idea of self-improvement. So I think a lot of people are broadly inspired by what happened with AlphaGo. So in AlphaGo, this was a Go playing program developed by DeepMind. And AlphaGo actually had two major stages. In the first stage, you learn by imitating human expert players. So you take lots of games that were played by humans. You kind of like just filter to the games played by really good humans. And you learn by imitation. You're getting the neural network to just imitate really good players. And this works, and this gives you a pretty good Go playing program, but it can't surpass human. It's only as good as the best human that gives it the training data. So DeepMind figured out a way to actually surpass humans. And the way this was done is by self-improvement. You can play millions and millions of games and kind of perfect the system just based on the probability of winning. So there's no need to imitate, you can go beyond human. And that's in fact what the system ended up doing. So I think a lot of people are kind of interested in what is the equivalent of this step number 2 for large language models, because today we're only doing step 1. We are imitating humans. As I mentioned, there are human labelers writing out these answers, and we're imitating their responses. So because we are in a space of language, everything is a lot more open, and there's all these different types of tasks. And fundamentally, there's no like simple reward function you can access that just tells you if whatever you did, whatever you sampled, was good or bad. But it is the case that in narrow domains, such a reward function could be achievable. And so I think it is possible that in narrow domains, it will be possible to self-improve language models.
And he's not the only one. So Demis Hassabis, who is the main guy, the big boss at Google DeepMind, he's saying that Google DeepMind Gemini, which is a large language model, will use AlphaGo style algorithms to boost reasoning. So again, this idea of kind of combining LLMs and AlphaGo, the things that we learned from AlphaGo, that seems to me the next big breakthrough. And it might be as big as transformers were. In fact, we'll see that very question posed to Demis Hassabis and to Ilya Sutskever. What is that next big wave in AI, that next big breakthrough?
Not sure whether I'm invading some proprietary area here, but do you have any idea what the next architecture after transformers could be? Jeff, you must have some idea.
If I did have an idea, I wouldn't say it in public until I had a publication.
Any idea?
No.
Ilya? Yes, but you cannot speak about it, I understand. All right. So,
So much for open science.
so let me move to neuroscience.
But let's rewind just a little bit, because there's another little piece that is kind of interesting in this whole thing. So I got to give credit to AI Explained on this one for pointing out this little thread. I believe I've read some of his tweets before, but I did not connect any of this to what's happening now in Q star. So this is Noam Brown, and on July 6th, he joined OpenAI. For years, I've researched AI self-play and reasoning in games like poker and diplomacy. I'll now investigate how to make these methods truly general. If successful, we may one day see LMs that are 1,000 times better than GPT-4. So the key to AlphaGo, part of it at least, was this idea of self-play. It doesn't rely on human knowledge, it plays itself, it keeps getting better, and it rapidly becomes far, far greater than humans could ever be, potentially, right? So in 2016, AlphaGo beat Lee Sedol in a milestone for AI. But key to that was the AI's ability to ponder for about 1 minute before each move. How much did that improve it? For AlphaGo 0, it's the equivalent of scaling pre-training by 100,000 times. Now here they're talking a little bit about scaling and scaling laws. Now, we're not going to go too much into the details, but here's a brief clip from Andrej Karpathy talking about scaling laws.
The first very important thing to understand about the large language model space are what we call scaling laws. It turns out that the performance of these large language models in terms of the accuracy of the next word prediction task is a remarkably smooth, well-behaved, and predictable function of only two variables. You need to know n, the number of parameters in the network, and d, the amount of text that you're going to train on. Given only these two numbers, we can predict with a remarkable confidence what accuracy you're going to achieve on your next word prediction task. And what's remarkable about this is that these trends do not seem to show signs of sort of topping out. So if you train a bigger model on more text, we have a lot of confidence that the next word prediction task will improve. But we can sort of get more powerful models for free because we can just get a bigger computer which we can say with some confidence we're going to get, and we can just train a bigger model for longer. And we are very confident we're going to get a better result.
And so basically what he's saying here is that if we just let these models think, if we just run it for a longer period of time, the same models that we have now, we just ask it a question and we give it a long time to figure it out. He's saying if we can discover a general version of that, the benefits could be huge. Yes, inference may be 1,000 times slower and more costly, but what inference costs will we pay for a new cancer drug or a proof of the Riemann hypothesis? Notice he uses the idea of having it do a mathematical proof, which we'll come back to at the end of the video. He's saying improved capabilities are always risky, but if this research succeeds, it could be valuable for safety research as well. Imagine being able to spend 1 million on inference to see what a more capable future model might look like. So what he's saying is that there may be a way, and keep in mind, this was July 6th that he said it. He's saying that there might be a way for us to use our current existing models to have it answer a question that we ask it, similarly to how a model that was 1,000 times bigger and stronger and smarter, as if that model answered it. So we can scale that up for this one particular question. It would cost a lot of money, it would take time, but it would kind of give us a glimpse into the future. Now, here's something on Reddit that people are claiming to be a leaked document out of OpenAI. Now, there's no verification for this, so we have no idea. But the news about Q star mentioned that it was very good at math. That seemed to be the thing that kind of spooked everybody. How could being good at math be so scary? How could being good at math be a threat to humanity? Remember when Noam Brown said, in the future, perhaps we can make these models, either prove certain theorems or at least state them. So basically make these novel math discoveries. And so here's a little clip where Ilya gets asked, can some next future version of GPT-4, like GPT-5, would it be able to do that? He has kind of an interesting answer. Take a listen.
Do you think the existing models or some, the next GPT-4, say GPT-5 or so, will be able to state a new non-trivial mathematical conjecture? I'm not saying proving it. I'm saying stating it. Who think it's possible within the next 5 years?
Are you sure that the current model cannot do it?
I'm not sure, absolutely. Do you know whether it can?
I mean,
let me give you an example of something creative that GPT-4 can already do, that most people can't do.
Now, Ilya gets interrupted. Later, they kind of come back to it, but we don't get a straight answer. But his first reaction was saying, are you sure that GPT-4 can't do that? Going back to Noam Brown, what he's saying is, what if we ask GPT-4 or some other model perhaps, but we use this method that he's talking about? Have you ever tried to export a video on your computer or export like some sound file and you have those settings at the end? You have a slider, and so at the left of it, you have, it's like low quality, and then you drag it to the center, and that's kind of like the standard quality, the MP4 or whatever, right? And it has a little arrow there saying recommended, just use this, right? But you could drag it all the way to the right and you probably get some error message. You sure you want to do that? It's going to take a long time to process. It's going to take a lot of computing power. Are you sure you want to do that? But let's say you drag it all the way to the right and you click yes, and the computer starts processing. And it's processing 30 minutes later, an hour later, 2 hours later. You see that progress bar slowly crawl across the screen, and at the end spits out this file that's massive. But the point is, you could produce something that's 1,000 times or 10 times or 100 times better than your MP4. You can take your original sound file or video file, or you can crank it up to the max and produce something that's much better. Here, they're saying that we could have a glimpse into the future of AI models. And I think that's what Ilya's saying in his cryptic little answer. He's saying, are you sure GPT-4 can't? Now, on the surface, we kind of know that probably it can't. A lot of people have been studying it. Microsoft has been combing every inch of GPT-4 to figure out everything it can about it. It doesn't seem like it has certain capabilities yet on this math front. But what if you spent, a million or many millions on inference, meaning on asking a question and getting the answer back? Inference is its answer, its sort of prediction, right? And the question you asked dealt with stating a math theorem or proving a math theorem or something like that. could it potentially produce some incredible result? So in this tweet, Joshua Bach says, word on the street is that Q star proved P equals NP, and the board drama was only a decoy to divert everyone's eyes from 750 OpenAI employees cashing out to buy a 7-year supply of ammo and groceries. You might be wondering, what does that mean? Now, he's kind of saying this tongue in cheek. It's not 100% serious, but we'll unpack this. But basically, it means that computers would be able to do certain highly complex calculations fairly easily and fairly quickly. With that in mind, let's get back to our leaked paper. If this is a little bit confusing, it'll all make sense in just a second. This paper is saying, furthermore, Qualia, so this is what they're calling Q star, Qualia has demonstrated an ability to statistically significantly improve the way in which it selects its optimal action selection policies in different deep Q networks, exhibiting metacognition. So metacognition here means thinking about thinking, or thinking about how to manage your own thought processes. So basically, how do we optimize our thoughts to achieve certain solutions faster? So let me read this really fast, and then I'll explain in a sentence or two what it means and why it's incredibly bad if it's true. Like really bad. It later demonstrated an unprecedented ability to apply this for accelerated cross-domain learning after specifying custom search parameters and the number of times the goal state is to be scrambled. Following an unsupervised learning session on an extended ad hoc dataset consisting of articles in descriptive/inferential statistics and cryptanalysis, it analyzed millions of plaintext and ciphertext pairs from various crypto systems. Via a ciphertext-only attack, it provided plaintext from a given AES 192 ciphertext by using tau analysis, achieving Project Tundra's alleged goal. In a way we do not yet fully understand, blank informed blank at NSAC the following day after confirming that the result was indeed legitimate and had not been achieved in any other way. A claimed full pre-image vulnerability for the MD5 cryptographic hash function with a theoretical computational complexity of 2 to the power of 42 bits, a massive number, was also presented but has not yet been thoroughly evaluated due to A, the technical sophistication of its arguments, and B, possible AES vulnerabilities being a considerably more pressing concern. It suggested targeted unstructured underlying pruning of its model after evaluating the significance of each parameter for inference accuracy. It also suggested adapting the resulting prune transformer model and its current context memory to a different format using a novel type of metamorphic engine. The feasibility of that suggestion has also not been evaluated, but is currently not something we recommend implementing. All right, so let's unpack this a little bit. So Qualia, what is Qualia? Qualia is kind of like perceiving the world. It's like your brain perceiving the world. It's the experiences of your senses, feeling, seeing, hearing, tasting, whatever, the world. And so this model, Qualia, has demonstrated an ability to statistically significantly improve the way in which it selects its optimal action selection policies in different deep Q networks. So what does that mean? So we've talked about Q learning before. It's basically how we train robots, how we train AI to learn a new environment. It's how we sort of reward it for doing certain things, whether that's playing poker or chess or whatever. It does something good, we give it an attaboy, and over time it figures out which of its sort of moves lead to which results. And it gets better and better playing it over time. And so the deep Q networks, that's just a neural network that is used to do this sort of Q learning. By the way, this is spinning up.openai.com. So this is OpenAI, a little subdomain that they have. I'll link it down below. But this is all their documents and tutorials on deep reinforcement learning. This is an educational resource produced by OpenAI that makes it easier to learn about deep reinforcement learning. What I find kind of interesting is that when you go to key papers in deep reinforcement learning, they have a list of like a bazillion papers here. But interestingly, the very first one is deep Q learning. And under that sort of umbrella, they're talking about this one, playing Atari with deep reinforcement learning, which is a paper by DeepMind Technologies. So before it was Google DeepMind, it was DeepMind Technologies. And it's talking about how to teach AI to play Atari with deep reinforcement learning, with Q learning. That may or may not be important. So this is saying after training it demonstrated this newfound ability that we've never seen before in these models for accelerated cross-domain learning. And so they're saying what they gave it is they gave it encrypted text. So similar to how we transfer various encrypted text over the internet, or how you might have a little code if you don't want the message getting out, right? So we gave it plain text in English or whatever other language, sort of a human readable text, and the encrypted version of that text. And so that was sort of the data set on which it was trained. And then it's saying that the AI model, this Qualia, it was able to decipher texts. So if you gave it a brand new encrypted text, it would just transform it to plain text, regular human readable text. So blank informed blank at NSAC. And so they're informing one person, informing the other that the results were achieved with this model. There was no cheating going on. That's in fact how it achieved it. All right. So what does all that mean? What are we talking about here? If this is real, what this is saying is this AI model can easily break any encryption. It will effortlessly translate any encrypted information into plain text. And this AES 192, so this advanced encryption standard. So basically, just think of it as very secure, very encrypted, your information is safe kind of encryption. So I gotta say, if this is a fake, it's very well written because it is hard to read. It's not like it just explains everything. So you have to kind of read between the lines what it's saying. Right? Nowhere in here does it scream out what this means and then 50 exclamation points. It's written, it probably would be written similarly as if it was indeed written from, one sophisticated AI researcher, like a computer science background to another. Like they're not going to over-explain things that both of them will understand. But what this is saying is basically this thing figured out how to break any encryption. Why is that a big deal? How big of a deal is it? Well, it's kind of huge. Basically, everything we do, we rely on encryption. From logging into our bank accounts, from transferring money bank to bank overseas, to a lot of like the government secrets, the corporate secrets, to it's almost hard to like list things out because it's like everything runs on software, everything runs on the internet, and everything that is worth that you don't want the whole world to see is encrypted. At this point, pretty much every web page you visit is encrypted. Very rarely nowadays do you get to a web page and it doesn't have the little lock icon off to the left. I know most Android phones, everything you use on there is encrypted. What would it mean? It's like taking all the locks off of every door, taking out all the doors, taking out all the walls, all the fences, all the borders, just anyone can go anywhere, but in the digital world, on the internet. If somebody had something like this, number one, they could steal all the government secrets, all the corporate technologies, hack into any bank, probably impersonate anybody. I mean, anything that requires a password to get in would be pretty much open. Like it's hard to even imagine what that would look like. Now, in reality, what that would look like is the governments would probably shut off anything that is connected to anything, to the internet. So here where Joshua Bach said, word on the street is that Q star proved P equals NP, which is kind of similar to what this is saying in a different way. And he's saying that while this is unlikely, cracking a major encryption algorithm could mean that an AI algorithm has bootstrapped itself to a level of mathematical understanding far beyond the best human mathematicians. I leave the implications as an exercise. And so like, what does that look like? Where he's saying in a good scenario, the United Nations have successfully outlawed the use of electricity and the zombie hordes have mostly died off. But perhaps the most serious outcome of this being true is far more scary, and that is that Bitcoin price goes to zero. It's gone because this just takes all your Bitcoins. That's it. Because that was the whole thing about Bitcoin is it's encrypted money, so nobody can hack into it, nobody can take it. So something like this could either crash Bitcoin to zero by you would be able to delete all of cryptocurrency now that I think about it. Or it could just siphon off whatever it needs, whatever. And then saying it can also, potentially do a lot more than this, than what they described here, but we didn't evaluate it because, one, we didn't really understand what it means. And two, we're kind of worried about this, like the security implications of this thing up here. And it kind of goes on to say it suggested targeted, unstructured underlying pruning of its model, and adapting the prune transformer model to create a novel type of metamorphic engine. This reads a little bit weird to me because I don't know. This could be just extremely well-written piece of trolling. I can't wait to find out, but I got to say it's well-written. But now that we've kind of covered what this means, so just imagine you're the person like X informs Y. Like imagine you're X or Y, and you're either the first or the second person that's kind of finding out about this, and you understand what the implications are. Because basically the global financial system is kind of at risk, completely vulnerable to attack. Anyway, so going back to this tweet, why I wanted to highlight this tweet is because that's a good take, I gotta say. So imagine this, right? So imagine that Q star is indeed this thing, qualia. You find out about it. You're one of the first people to find out about it, right? You're talking to a few other people. They freak. They say, we need to shut it all down, cancel the whole thing, delete it, throw away the key, which probably sounds like a good idea. Maybe that's how the whole thing started. But at some point, other people start thinking, they're saying, look, even if we throw our model away, our software away, like everyone's moving towards this. So if it's not us, then somebody else, this is going to happen. Maybe in the US, maybe in a different country. What will be the repercussions of that? So as they're running around trying to shut down OpenAI to prevent this from getting out, other people have a different idea. What if all the OpenAI employees, the 750 or whatever OpenAI employees, what if they cash out, right? Because the company is now valued at whatever, 90 billion, 86 billion, whatever that number is, right? So they cash out, get their millions of dollars, right? While the financial system still exists, and buy a 7-year supply of ammo and groceries. Why 7 years? I'm not sure. But the point is they get off the grid and go, live somewhere with their ammo and groceries. Because again, if this is real and this information gets out, I mean, that means all the markets crash just at the very minimum, because you don't want to have your entire net worth or a lot of your net worth in these digits that are floating on the internet when people can now just attack everything that those digits represent and potentially even just erase the digits themselves. Who knows? Anyway, so that was a fun speculation. Again, we don't know if that paper is true. We don't even know if Q star is real. But what I think really is so interesting to people, what really brings them in and gets them hooked into discussing this stuff, myself included, is that for so long, all of this stuff was science fiction. And just in the last few years, it's no longer some far distant future. A lot of this stuff seems like it's right around the corner. For example, just a few years ago in 2020, AlphaFold figures out how to predict how proteins fold. Now, proteins are the kind of the building blocks of life. They're like little factories of life that make everything that we think of as life happen. And we kind of knew the amino acids, like how those fit together, like which letter came one after the other. So this part, so in other words, like this part, the letters, the amino acids, that was, fairly easy for us. But in order to make proteins work, these little letters, these little strands had to fold in this highly complex 3D shape. And guessing that shape was incredibly difficult. So there's this idea, Leventhal's paradox, that says that searching for the correct folded state of a protein by just like a random search among all possible configurations can take an enormously long time. Yet those proteins, when they're created, they fold in seconds. I was trying to get the comparison to kind of visualize how many different variations there are basically. So the number of atoms in the universe, right, the entire universe, is 10 to the 78 to 10 to the 82nd. And so a single protein molecule composed of a chain of amino acids can theoretically adopt an astronomically high number of configurations. For example, a modest-sized protein of 100 amino acids can have more 3D configurations than there are atoms in the observable universe. Think about that for a second, right? Everything's made up of atoms. The observable universe is vast, and these proteins can fold more than that. There are more shapes they can take than that. So guessing, brute force approach to try to guess how that thing folds, I mean, it would be impossible. It would take an astronomically long time. In the past, it would take hundreds of thousands of dollars to figure out how they fold. It would take, months or years of people's lives using a process called X-ray crystallography, which, interestingly enough, that's what Walter White from Breaking Bad, that was his claim to fame. That's why he was such a good scientist. He discovered some new process of X-ray crystallography. That was the big breakthrough that allowed him to found that company earlier that he had to leave. I apologize. That's a tangent, but kind of interesting. Anyway, so it's incredibly complex. There's no way to guess what it is. And it took us a very, very long time to figure out how to do it. Or each one would take a long time. Then comes AlphaFold. And in 2020, so not that long ago, that AI started figuring out how to fold these proteins. It would give us these little structures and say, oh, it's going to look like this. So that's what we have now. That exists. That's what AI can do. And that's important to understand. So, when you're reading something like this, where it's saying, well, we trained it on encrypted text on a data set that has, encrypted text plus plain text. And that's what this new sort of AI was trained on. And it figured out how to decipher those texts. That might sound like science fiction. That might sound like a joke. But we already have an AI system that is able to predict 3D structures that can fold in more ways than there are atoms in the observable universe. I hope that makes sense. I'm saying that this isn't Harry Potter fan fiction. This is where we might be approaching something like this. Or if this is real, we have something like this out there. So, well, that's it for me. I hope you enjoyed that. And whatever else, these are exciting times to live in. My name is Wes Roth, and thank you for watching.